Hi. Oop. All right. Sorry about that. Just testing the mic. But welcome to episode 2 of MakerBot Chats. My name is Felipe. I'm creative director here at MakerBot. I got Alejandra behind the scenes. Actually, if you could mute the video, that'd be great because I'm hearing myself. She's actually giving me some pointers over the headphone. And yeah, welcome everybody to the second episode of MakerBot Chats. It's actually great to have you all here in, well, my living room. I'm joined by our method. And today we will be talking about, our material offer, specifically. Give me one second. All right. So last week we introduced we started talking about oh wow, there's something really loud going on. Let me do one thing real quick. All set. Here. That should be better. Okay. Just waiting for some more people to join. But I'll do the intro one more time. My name is Felipe. I'm a creative director at MakerBot. And as I was saying, today we are going to be talking a little bit more about materials. Last time was our first one. Uh, you're here live at my living room, which is great. Staying inside, as most of us are. And we just wanted to do a quick rundown of some of the new materials that we have on MakerBot, then specifically talking about labs, one of the newest additions to the Method platform. So I'll be doing a quick rundown of the newest extruder that we introduced probably like about a month ago, and how have I been using it, what can you use it for, what types of materials are good with the labs extruder. And as usual, please do send questions our way. We'll keep an eye on the chat on YouTube. And also, if you have any follow-up questions, we will be answering them at hello@makerbot.com or felipe@makerbot.com. That's FELIPE at makerbot.com if you have any questions. And I'll just get started. This should be fairly I guess straightforward. We want to talk about more about the materials that you can use with the printer, right? So what types of material does the printer support out of the box, and what materials can you add on if you incorporate things like the labs extruder? So starting with the extruders that can come with one of the models, so either Method or Method X, this machine right here. This is the Method X, and it comes with two extruders, one for material and one for support. The set of extruders that come with Method X are called the 1XA and 2XA. The reason for that is that we have dedicated extruders for whether you're using a specific material or a specific support material. It's important not to mix the materials so much, especially some materials that might have different melting temperatures, because that can actually cause, ultimately damage your extruders. They can create clogs in the extruders and prevent the material from flowing properly. So we have these two sets of extruders. The first one and 2, works with Method and also with Method X. So if you wanted to add more capabilities to Method X, you can buy those as well. I have both sets. The second set, 1XA and 2XA. So it's these extruders right here. You can actually see the diagram here to my right. Yeah, my right. Where I have both of them. They're fairly similar in nature. Then, there are some questions around how do they relate to the Red Plus. They're not magnetic, actually. They are mechanically attached, but also super easy to remove. Let's see. Yeah, you guys can see the top of the printer coming off. I'll remove one of them right here. It just has a latch on top. Now I'm so used to it that it's also easy for me to do it almost without looking. So, give 1 second. There we go. Oops. Here. All right. So I have the labs extruder loaded in the printer. The way that it attaches to the printer, so for those of you who are familiar with the Replicator Plus system, it's just you basically nest it in place and the magnets guide it to the position, right? With Method, it's a little bit different. It just sits in a little hole on top of the gantry. And then from that hole, you have a latch that closes up and just keeps that extruder firmly in place. We needed something a little bit stronger than just the magnet. The magnet is great for the replicator system, but in this case, the gantry moves a little bit more aggressively and a little bit faster. So because of that, we wanted to have a really tight connection to to the extruder itself. Hence, well, that's why we made a latch system as opposed to just the magnetic system. So these two sets of extruder come with either a printer, and extruder 1 and 2 are great for printing things that will use PVA as support. So think about nylon, PLA, tough material. I actually have, let's see if I have something. Yeah. So this is a part printed in a tough material, right? It was printed with the extruder 1 and the support was extruder 2. PVA is a great material because it's water soluble, right? So it's super easy to remove once you're done printing, and makes the experience so much better than sometimes removing the breakaway supports. And with Method X, you have extruder 1X and 2X, which are capable of printing materials like ABS, ASA, and the support material, which is actually one that I got loaded here on the Method. As you can tell, it's a little bit tight in here, but I've got the support material for Method X and for extruder number 2X. It's SR30. It's also soluble, but this material is dedicated for different thermoplastics such as ABS and ASA. And it's actually made by our parent company Stratasys, but it has similar properties than PVA in that it's water soluble. You do have to add an agent to the water to dissolve it once you're done, but it actually creates impressively looking parts, right? Once you remove the support, once you dissolve it, you can see it with the part that I'm holding right here, this fan. And I'll talk about the fan in a second, but it's just so easy to remove, and it's just so much effort and time saved by not having to tinker that much with the filament itself. Now, if I was to talk about the new extruder that I was mentioning, is our LABS extruder, right? Which is the one that I just took from the machine. I'm happy to have two of them with me. And what happens with the LABS extruder, so it comes in this really neat package. Let me show it to you guys. So this is how there we go. This is how the extruder comes, right? Better light here, yeah. You open up the box, you expose the extruder, really nicely packaged. Kudos to Vishnu and Andrew for creating an awesome product. And inside of the product itself, as you can see in the diagram, you'll have a little plastic box with a set of tools. Specifically, three things. First up is going to be a replacement nozzle. So I don't know, what systems are you guys familiar with? You can let me know in the comments if you're using Rep Pluses, Rep 2s, even other brand printers. But look at the length of just the sheer length of the nozzle, right? It's almost like 3 inches long. This is just a replacement nozzle in case that the LABS extruder is meant for you to introduce third-party materials from the side. So I'll talk about this side mount in a second. But the idea is that you don't have to use only MakerBot materials. You can use third-party materials. In this case, I'm using Polymaker. I've used Kimia. I've used Jabil. There's quite a few other materials that are not provided by us. But now with the LABS extruder, you can simply drop into the machine. And the main goal here was to create a subsystem, right, a modular element for the method that you could easily replace if you came into any issues with it. So extra nozzle here, a little bit, there we go, a little bit closer to the camera. I know it's a bit dark, the light is over here, but the extra nozzle. And then, of course, in order to change that nozzle, and that's what the diagram to my right is showing, right? So you see this little spatula thing here, that's this key element, right? It's a bespoke key that will help you remove that nozzle from the extruder. So the extruder itself has a safety, unlike other extruders from the method, it does have a lock-in screw, right, that actually keeps the nozzle in place. And it comes with a little hex key, so it's a safety key. Let me put it closer, there we go. Safety hex key, that sort of flower or star-shaped key that allows you to first remove the safety screw, and then once you've done that, you just simply pry it with the lever. Here we go. Oops. Trickier to do it in first person than looking down at it. And here we go. And taking out the nozzle and replacing it if needed, right? So the idea here is that with LABS, you're able to not expose the full system to any sort of weird or experimental materials that you might want to test, but actually just focus on the single part, that's going to be the extruder, to manage that new material that you might want to test out with. With the labs extruder, it's actually great to know that there are other possibilities. I know that last time I brought up some materials already, with me, specifically flexible materials, which I love. In this case, this is a SEBS material. It's just a tire, right? I'll put it closer to you guys so you guys can see. And I've been having a blast with it. But a lot of people asked me, last time, how does SEBS compare to TPU? So I just got some TPU and printed with it. It's also possible to print with TPU with the labs material. Let me put the light over here so that you guys can see. There we go. The tire. So this one is TPU. I'll have to keep the light here. And this one is TPU. This one is SEBS. I'll show you guys how these actually, there we go, how it looks, on the diagram. But it's just a small toy tire, right? Both of them are using 0% infill, so they are rather flexible. The thing with TPU is that, well, I see two things. First of all, it's kind of like too shiny, right? And I also printed it on black SEBS. So SEBS has this matte finish to it, which I really like, especially for this type of application. And TPU seems to be, the durometer seems to be lower, so it's much more flexible than SEBS. Maybe like 10%, 20%. So both of them are rather flexible. But it seems that the layer attachment is not as strong as with SEBS. Probably I could tinker a little bit with the the specific settings that I'm using to print it with, but so far, just with the out-of-the-box print settings that I got from the supplier, I really like how SEBS behaves. It's just so steady, so stable, I would say. And that's another thing that Labs adds. So I want to show you how does Lab look when you're using MakerBot Print. So when you're using MakerBot Print, and in this case, I'm just connecting to the machine. There we go. So the machine actually knows that the extruder is missing. I can do the quick demo right now, where I go into the machine, putting in the. Oh, you actually can see the extruder popping in on that. So that view on the top right, it's actually the camera from the printer, so you can see my hand in there. It's got a pretty stable connection, so I can directly control it from the computer and from our free MakerBot Print software, which is open, for you guys to download, use. You don't have to have the printer yet. You can just tinker with it and play with it some. So once I put the extruder in, here we go. Now the printer knows, I can go here to settings. Now the printer knows that I've loaded a labs extruder. And the great thing about that is that actually it opens up quite a few more settings for me to play with. So I will have to specify the material that I'm using, right? Unlike what happens with the regular extruders, where they will automatically recognize the type of material that you're using. Since in this case, I will be side loading, let me come back here. I will be side loading the material to the printer. The printer will not be able to recognize which material I'm using. So in this case, I've got Polymaker Polymax PC. It's also a pretty good material. I actually printed this gear last night. Super sturdy, super stiff as well. Really good layer detail. And as you can see, we also have a side mount that you can download from our labs resources page. This was developed by one of our industrial designers, Quincy. And it's just basically a side mount. You attach the PTFE tube, and that will route the filament through the side port of the machine. So the machine is you're not longer only able to load material through the drawers, which I highly recommend if you're using MakerBot drawers, because the drawers will keep the material super dry and basically in a controlled environment. But if you're trying to experiment with other materials that are not as sensitive to humidity as PVA, for example, then the side mount is also, let me put it back in there. There we go. It's also a great option, right? Because now you can use any sort of third-party material that you might be used to using, and ultimately, experiment with the machine. So I was showing you guys here how many settings you can expose here. In this case, I've got the support 2x loaded. That means I'm going to use SR30, but I can go all the way, for example, if I wanted to create custom settings and see, if I want to change settings on the printer, like the chamber temperature, going all the way to 85C in the chamber temperature. The extruder temperature, I think it goes all the way to 260 or 300, I believe. Let's give it a try. There we go, 300C. So that's pretty darn hot, right? If you're thinking about some of those top of the line materials, 300C will cover you for most applications, changing the roof thickness, changing the speed at which the roofs are printed, the floors. So it basically exposes all of the additional sort of settings that you might want to alter for given materials, and allows you to experiment and have a wider range of options for the printer, which is really interesting, especially once you're if you come across other materials that you're interested in, or if you come across materials that you were already using and you want to continue to use with our platform. And the great thing about the platform itself is that, as we've talked in the past, it's much more stable, much more controlled. So what I love or what I like the most about Method itself is that the chamber is enclosed, and not only enclosed but heated, right? So I can have the printer right up against the wall, the window, which for me is great because it's better ventilation. I don't have to worry about it too much, and the printer keeps itself warm, right? So you guys know, probably you've experienced it in the past with other open chamber printers. You can, if you have it against a draft, if you have it close to, say, an AC outlet, it's highly likely that your parts can delaminate, right? Your parts can be popping right out of the build plate as it's printing. With Method, that's simply not the case, because the printing chamber is completely enclosed and heated. So you have these two ports on the sides that are constantly uh, funneling heated air to the build chamber, and keeping not only the build plate but the whole build envelope, the whole build volume, warm and up to temperature, the temperature that you need for that specific material. So with that, I'll just do a quick rundown of some of the experiments that I've done so far. I've started with these tires, which I love. Again, if you guys want to know more about the settings, or have specific questions about the model, post them in the comment section, or send us an email about them. So this is SEBS in different infill configurations. This is 10%, right? Fairly flexible. This is 20% infill. It's a little bit stiffer, right? Of course, as you vary the infill of the material, it's going to change and alter how the material behaves. And this is the same material, SEBS, but at 0% infill, so basically hollow. And it's super squishy. It's like kind of super satisfying, right? To just use it. And full disclaimer, I've been printing a lot of these little tiny wheels. Probably will do a tiny truck for myself or something. But moving on to another interesting material, which is this, here we go, dual gripper from one of our customers, All Access. They are based out in Texas. And this was printed with ABS carbon fiber, right? So it's a rather stiff, rather strong material. What they were looking to do is to print a fairly strong but light part, right? So this is a gripper that will mount uh, to a robot, right? The robot then will be able to connect to two gripping modules here. So basically, you can see the holes here, and also the diagram on my right. The holes will actually allow you to mount, or them to mount, an additional set of hooks to the robot. So now they have two dual hooks, right? And here we go, this might be better. They have opposing angles so that you can have one hand facing one direction, one hand facing the other, and sort of toggle between them as they go. So yeah, really interesting, really nice finish, right? This material is from Kenya. It's called, so we're saying, ABS carbon fiber. Super stable. It prints with SR30 supports, which are also super easy to remove. And you can see, right, how clean even the logo here itself. So they actually engraved the logo in the STL, and it's just so crisp, right? But for you guys to see, there we go, just catching the light properly. But the logo here is so smooth, and the layer finish, it's super hard to distinguish the layer lines, right, with this material. So really impressive material, ABS carbon fiber. And then another part that we got from them is this CNC chip fan, right? So I was showing this part before. Here we go, against a white background. But this chip fan, they used it in a CNC machine basically as a replacement part. They used to have a metallic one, but it broke because at some point um, one of the sections actually hit apart and broke, right? And they were able to print it out of polycarbonate, which is what I've used also here. Polycarbonate uses SR30 supports, which are also super stable. And now they replaced a part that's probably a couple $1,000 with a simple printed part on the method, right? So also great layer resolution, great settings, and ultimately super strong. There's a video out there. We'll link to it on the description of this webinar. But there's a video showing how fast this part has to run in order to blow away all of the little chips, all of the little leftovers of the CNC machine once it's done milling the aluminum parts. So it's great to see, and ultimately shows the strength of the material with also a fairly complex. Here, better to see it against the white background. With a fairly complex part, you can see how it, the shimmer against the light. I really like, just because of the layer resolution. It's rather nice. Then I have here this part made with the material that I've got loaded in the machine. So this is polycarbonate. It also uses SR30 as supports, and I just made this helical gear, right? So a fairly straightforward part, but it requires a lot of stability, especially dimensional stability and thermal stability for that, in order to create these very accurate circles, right? So you have the concentric circles. We see a lot in many machines that are not as stiff as Method, that don't have a real gantry. Like, many machines just use basically little aluminum rods and maybe side panels to stiffen them up, but they will wobble a little bit, and it's not so easy to perceive if you're printing something fairly square. But as you start printing circles, I'm sure you guys have seen, it's so hard to keep the dimension accurate every time, because you're not longer asking the machine to behave stably in a single axis, but in both axes at the same time, right? As it's describing the X and Y circle looking from the top. I'll actually try to get a piece of hardware for next time to show you guys how tight the tolerance on this guy are. But yeah, I mean, for me, it's just been impressive. And the material itself feels really stiff. I'm a little bit limited on the testing that I can do in my living room, but I want to test out, how does it compare to other materials? At least from Polymaker's datasheet, it's impressively so. It feels like that, but I still need to sort of put it to the test and see how much load can it handle. And I'm starting to get to the end of the conversation. I'll start to look closely, or more closely, to the questions that you guys have, so that I can answer some of them. Keep them coming up, and I'll keep going through some of these other materials. So this is another flexible part. But will there be a MakerBot Labs pellet extruder for the near future? Wow, that would be awesome, right? Just to load the pellet yourself. Right now, there's no option for us to print with pellets. I've seen a few systems that actually take the pellets and extrude your own filament. With the Labs extruder, you can use any sort of filament source. So if you had the machine that actually made the extrusion of the filament, that's 1.75 millimeters in diameter, then you can 100% load it to the machine. So that's super possible. However, the big catch there is that you have to really be able to control the bead diameter, right? Otherwise, you can cause issues as the material extrude, as you were seeing here before. It's important, and that's why we start. We would recommend, or I would recommend, starting with the MakerBot materials first, that are super well tested, up to spec, just spot on, and are able to print seamlessly, and then explore some of the let's say extended applications. Did you already try UltraFuse 316L from BASF? So no, no, but we are actually working with BASF. We are really part of this labs collaboration includes them as a material supplier. They have so many exciting materials for us to use. I don't have any of the BASF materials here just yet. I'll probably get some more as we have. If you have more of these, send them my way. I'll see what we can do to print some of those samples out and show them here. What's the maximum temperature that the experimental extruder can go to? So that's 300 degrees. I think I showed you guys in the interface here. I'll bring it up again. But yeah, it's impressively hot, right? I mean, at that point, here we go, extruder 1. So extruder 1 is going to be my my labs extruder. So 300 degrees, you're talking about some serious temperatures for the extruder, and not only the extruder, but also the chamber itself. I'll also be, I want to give a quick shout out to the promo that we're running. I know that it's going to sound a little bit weird, but This is such a great, I mean, I've talked about it before, but it's such a good deal. There's now a 30% off on both Method and Method X. I would highly recommend that you guys check it out. If you're curious about it, send us an email at hello@makerbot.com, or just go to the website, makerbot.com, because seriously, for the price, this is a beast of a machine. Well, I'm super happy with it anyways. But I'll go back to the gear here, maybe. I like that one a lot. And go back to the questions. So could you show how you have the side-loaded filament threaded into the machine and loaded into the labs extruder? Of course, this is going to be a little bit trickier and might require that I move myself. But, so, okay, let me get rid of that element there. All right, so I'm holding my laptop, so you'll have to bear with the wobbliness. Here's the material side mounted, right? The machine itself comes with two auxiliary ports right here, which you can see. I'm sorry about the glare, right? Let's see. There we go. So you can see out there it says aux1 and aux2. Basically what you're doing is loading the material through this PTFE tube all the way to the regular, to the regular outlet and into the extruder. So here you can see both extruders. In this case, I've got the last extruder. And somebody was asking at the beginning, how are the extruder mounted? So this is how it actually attaches. So it has a highly tight mechanical rib. It's just a clamp. Here we go. Right, you can see how it pops out. And here's the extruder. Right, so you're using it's basically an interchange of the filament. Right, when let me set this back up. So as I said, there's my clock, sorry. Moving in these tight corners and tight space, it's a little bit hard. There we go. As I was saying before, it's super straightforward, right? You're just routing through the final section of the routing. It's pretty much the same, whether you're using the drawers or if you're using the side mount for the labs extruder. Is there any special requirements for the chamber temperature or build platform to print? Okay, sorry. Is there any special requirements for the chamber temperature or build platform to print special materials like carbon fiber or polycarbonate or TPU? Yes, and that's kind of the cool thing about this guy, right? It gives you the flexibility to play with that. Depending on who the provider is, the manufacturer is, they will have different requirements in temperature, right? Whether that be chamber temperature, nozzle temperature, print speed, and all of those you can change once you have the labs extruder, right? So if you have the labs extruder, that just sort of opens the possibility for you to tinker with all of those settings. It's really useful, and also allows you to experiment a little bit more, right? Because you can go either a little bit hotter, a little bit cooler. For example, with SEBS, after playing with it some, so our engineers found out that turning the chamber temperature a little bit more allowed you to have so much stronger, layer addition, which is great, especially once you're trying to squeeze this part as strongly as you want. Can you show side loaded? I think that we got that covered. Is there any special requirement? Is it possible to have both the labs extruder and another model material extruder running simultaneously, or do you always have to have the support extruder? At this time, no. At this time, you have to have the labs extruder with one of the material extruders, whether that be extruder 2 or extruder 2X. So that means PVA and SR30 at this time. I know that we're working on some stuff. However, and I think I know what you're thinking about, like trying to print with two materials. So maybe you can do an overmold simulation where you have instead of using support material, you have part of a part made out of one material, part of the part made out of another material, which I think would be a great application, right? If you think about sort of prototyping a toothbrush or a part that has two different durometers on it, that'd be super useful. The straight answer right now it's no, but it's definitely something to talk to our engineering team about. And with that, I don't know if you have any more questions, but I would say, send your questions our way. I don't want to take too much of your guys' time. It's been great to have you for a second time here in my living room. If you have any questions, don't hesitate to reach out to hello@makerbot.com. There's also Felipe at MakerBot.com, so Felipe at MakerBot.com, and of course our social media at MakerBot and at MakerBot in Twitter as well. If you have any specific questions, if you have suggestions of what could we show more of, what would you like to see in future episodes, and I'll say it again because it's a pretty darn good deal. You should look into that. If you're interested in the method, now is the time to get it. It's 30% off. That means that the standard method starts at 35 and something $100. It's a beast of a machine for that price. I would just look into it. But in any case, do let us know if you have any more questions, if you would like to see other subjects covered in future chats, and I'll be here next Wednesday. Oh, different living room because I'm moving, which is going to be super exciting, but probably same little corner and super tight as this is. But yeah, let us know if you have any more questions, any more things that you would like us to cover and talk about. But for now, thank you for watching, and we'll see you next Wednesday. Have a good rest of the week.